Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the properties of covalent compounds. Previously, we discussed polar and non-polar covalent molecules. We learned that polar covalent molecules are formed when the atoms involved in a covalent bond have different electronegativities. As a result, the electron pair is shared unequally. We learned that non-polar covalent molecules are formed when the bonding electron pairs in a covalent bond are shared equally. We discussed dipole moment. We learned that dipole moment is the product of the magnitude of the charge at either end of the dipole multiplied by the distance that separates the charge. We also learned that dipole moment is a vector sum of the bond moment in a molecule. In our lesson today, we will describe the properties of covalent compounds, including the effects that heat, electricity, and some solvents have on them. Students, keep in mind that these are just general properties and that there are always exceptions to these rules. Let us begin. Unlike ionic compounds, a lot of covalent compounds are found in gaseous state when they are at room temperature. Methane is a good example of a gaseous covalent compound. It is the simplest compound of carbon and hydrogen, both of which have similar electronegativities. When methane gas is cooled, it condenses and turns into a liquid. If it continues to be cooled, it eventually turns into a solid. Some other examples of covalent compounds include diphosphorus pentoxide, carbon monoxide, and carbon tetrafluoride. Covalent compounds often have relatively low melting and boiling points compared to ionic compounds. I am sure you recall that ionic compounds have high melting and boiling points. This is because it takes a lot of energy to break apart the forces that hold together their positively and negatively charged ions. Thus, all of the ionic bonds have to be broken in an ionic compound in order for the ionic compound to melt. In covalent compounds, there are no bonds that need to be broken. This is because covalent compounds form distinct molecules in which the atoms are bound tightly together. The molecules do not interact with one another except through relatively weak intermolecular forces. This makes it very easy for them to be broken apart. As a result, it does not take much energy for covalent compounds to melt and boil. Like ionic compounds, covalent compounds are not electrically conductive in solid form. However, unlike ionic compounds, covalent compounds are also not electrically conductive in molten form nor in aqueous solution. If solutions containing covalent compounds are connected in a circuit, no chemical reaction will take place at the electrodes. Thus, nonpolar covalent compounds are non-electrolytes. Covalent compounds also are not usually very soluble in water. There is a saying that like dissolves like. This means that compounds have a tendency to dissolve in other compounds that have properties similar to their own, or that have a particular polarity. Water is a polar solvent, whereas most covalent compounds are nonpolar. Thus, most covalent compounds do not dissolve in water. Students, let us try an activity. In a moment, you will see several sentences appear on the screen, one at a time. Read each sentence carefully and fill in the blank spaces with the appropriate word.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, everyone. Were you able to complete all of the sentences correctly? Let us look at each sentence now. Most covalent compounds do not dissolve in water. A lot of covalent compounds are found in gaseous state when they are at room temperature. Covalent compounds form distinct molecules in which the atoms are bound tightly together. Covalent compounds are not electrically conductive in water. Covalent compounds often have relatively low melting and boiling points. Did you choose all of the correct words? If so, great work! Let us continue our lesson by learning about a few more of the general properties of covalent compounds. Covalent compounds have a tendency to be soft and squishy compared to ionic compounds. Ionic compounds are much harder because the ionic bonds that hold together their crystalline makeup causes them to be very inflexible and difficult to move. Covalent compounds, as we discussed, have distinct molecules that can easily move around one another. This is because they have no firm bonds holding them in place. As a result, covalent compounds are often quite flexible. You can think of ionic compounds like building blocks that connect together to form solid structures. Covalent compounds, on the other hand, are more like a pit of free-moving balls. If you were to jump into them, you would move right through. Covalent compounds also tend to be much more flammable than ionic compounds. Hydrocarbons are covalent compounds. The main reason that hydrocarbons burn is because they contain carbon and hydrogen. The atoms of these elements react to form carbon dioxide and water when they are heated with oxygen gas. Since carbon and hydrogen have similar electronegativities, they are often found together in covalent compounds. As a result, more covalent compounds are flammable than are ionic compounds. Students, we have time for one last activity. Please list all of the general properties of covalent compounds that we discussed in this lesson.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. I wonder if you were able to remember all of the general properties of covalent compounds that we have discussed. Let us list them together now. A lot of covalent compounds are found in gaseous state when they are at room temperature. Covalent compounds often have relatively low melting and boiling points. Nonpolar covalent compounds are non-electrolytes. Covalent compounds have a tendency to be soft and flexible. A lot of covalent compounds are quite volatile or flammable. Great work, everyone! In today's lesson, we learned about the general properties of covalent compounds. In our next lesson, we will learn about the valence shell electron pair repulsion theory. This brings us to the end of the lesson for today. Until next time, thank you, teacher. Thank you, students.